Cresswell, the member of the yellow team, the spray booth with both dampeners open. Team members Daniel, Sherna, Clinton, Clayton. Our outline today lists objectives, background, theory, results, and then brief conclusions. Our objectives is to learn how to model dynamic systems with Excel, observe the impact of parameter values on the dynamic response, and acquire a response of the system with a frequency input. Our system is, much like Brent's, is a paint booth with three systems of filters and two dampeners, which, like I said, are open. The importance of doing our experiments is to hopefully try and prolong the life of the filters and learn what works best to keep the system running as long as possible. Block diagram, our input motor power, then which is our input, and our output is our booth pressure, which is as the filters get clogged up, the pressure will rise. So therefore, you need to change them. Theory, briefly, we've been through our steady state enough. Our frequency response and model, we're looking to get, by inputting a baseline and an amplitude, we're looking to be able to find a gain, time, gain, dead time, and our time constant. Like we said, our steady state is for all of our ranges, which is from 5 to 30 centimeters per water. This is a description of how we analyzed our steady state. As you can see, we got all of our parameters here. Our FOPDT modeling equation with our parameters and our input balance or outputs. This is our data for that. Our step up, step down. This is our gain values compared to our model system. As you can tell, they're relatively close, actually really close. So there wasn't a huge amount of error there. But our tau values, as you can see, were pretty different. Like I say, those are our tau values in brown and modeled in green. There was a little more consistency in our dead time, but still not near as good as our gain. This is our frequency response. As you can see here, our T is measured by the bottom of the peak of our input to the bottom of the peak of our output, and our delta C here, and our time to do a complete revolution. This is our Bode response here, or frequency response, or Bode. You can see our ultimate frequency, which is the point at which the phase angle is 180 degrees, is 2.2. Able to get our order, our gain, our KCU. This is our the equations used for our modeling. This is our model. The model is in red, and our actual is in blue. As you can tell, it's a little different, but it's relatively good data. And our amplitude is 5.2%, baseline 52%, gain to be 2.2 centimeters per water. Dead time was 0.14 seconds, and time constant was 0.2 seconds.